All right, so now let's go through a thought experiment. We've just analyzed what happens when we combust gasoline to produce carbon dioxide and water. And we'll see why whenever we combust a hydrocarbon and oxygen, the products are always CO2 and water. And we'll see that thermodynamics is going to tell us exactly why that is. But let's focus on a slightly different issue for a moment. Let's ask, is it possible to burn octane, that is gasoline, to release energy but do no work if the external pressure is constant? That means that P is equal to a constant. Now, to answer this question, we always write down the first law of thermodynamics. So let's take this case. Delta U of the system is equal to the heat plus the work exchanged between that system and the surroundings. So if the external pressure is constant, we already know how to write that term. We have heat released minus P delta V. That's the work term. So is it possible to burn octane and release energy but do no work if the external pressure is constant? The answer is no. The first law of thermodynamics tells us exactly why that is. What about if the temperature is constant? Well, if the temperature is constant, we know that delta U of the system is equal to Q plus W. And if the temperature is constant, the internal energy of the system is constant. So that means that that's equal to 0, which means that Q is equal to minus W. So is it possible to burn octane and release energy but do no work if the temperature is constant? No. What about if the volume is constant? Well, we write down the first law again, and it may seem repetitive to write the first law of thermodynamics down, but I can tell you when you're solving these problems, it's the most important thing to do. So we write down the first law again. Change in internal energy of the system is Q plus W. And if the volume is constant, we know that the work is equal to 0, so the change in internal energy is equal to Q. So is it possible to burn octane to release energy but do no work? Yes, if the volume is kept constant.